Oh, hi there. Thank you for showing up here learning. This topic is new. We will cover it next week, but you can learn it now. It's uh, it's something that you're ready to learn. So you can absolutely teach yourself through Delta Math and through this video. So when we have quadratic linear systems, what's that talking about? Well, I'll give you a brief look. If I have something like y equals x squared, a system of equations of f of x equals x squared, and then another one, g of x equals 2x plus 5, whatever. Oh, it crosses. The line crosses the parabola at that point and that point. Basically, we're finding where a line crosses a parabola, linear quadratic systems. Okay, we can do these in the same types of ways that you did linear systems, where you just had two lines. Here we have a line and a quadratic. We can have as many as two intersections, as few as 0, and in some cases we can have one intersection. Okay, like okay, let's keep going. So let's take a look at the graphing ones and how we do those. So we want to graph y equals x squared plus 8x plus 18 and 2x minus 2y equals minus 16. So we're going to drag the dots and move this parabola around. Whoosh! How are we going to do that? Well, can it factor? So you might check, can I factor this and figure out where the roots are? And that would tell me where to put it. Multiplies to 18 and adds to 8. Nah, can't do it, can't factor. So let's complete the square to find out where the vertex is. The vertex is going to be at -4. And it's going to be such that, so -4 is the vertex. How did I do that? Well, I completed the square very quickly. So to graph this one, let's just go ahead and I would complete the square here. Well, there's multiple solutions available. Let's just say that. So if I have y equals x squared plus 8x, let's put this all in brackets, and we're going to take half of that, which is 4, and square it. So plus 16 minus 16, and then have plus 18 there. Then we're going to see that the vertex is at 2, and the x value is -4. So it's going to be x plus 4, squared. That's this part. Minus 16 plus 18 is plus 2. Okay, so we complete the square. And then we move it around. You move the parabola by dragging the dots. So I'm going to drag the vertex over to 4 and up to 2. Okay, so there's that. And then 2x minus 2y equals minus 16. Ugh! We have to convert forms again. 2x minus 2y equals -16. So we're going to divide everything by 2 to make this easier. X minus y equals -8. And now subtract x from both sides. So we have minus y equals minus x minus 8. Flip all the signs. Y equals x plus 8. Okay, so that's pretty easy. Graph the line by clicking twice. Boop, boop. That's the line x plus 8. And so then we read the points of intersection. The points of intersection are -2, 6 and -5, 3. Okay, you know you could flip all the signs, right? That's just multiplying both sides by -1. Okay, so now you just put in your things. You have two solutions. The answers are -5, 3. It's going to want me to input that bracket, and bracket -2, 6. You're going to use your tools to graph and then apply your graphing to solve these linear quadratic systems. You got to do some algebra, you got to do some doing, okay? I don't think you need to see more examples, and we will go over this in class. So if you're already here, you're kind of ahead of the game. So great. Ask me your questions by email, send me screenshots, and I can help you out. Okay, now if we want to solve these algebraically, how do we do this algebraically? All right, well, they're using y equals notation, but I prefer function notation for these. So I'm going to copy them down as two distinct functions. Here we go. F of x is equal to x squared plus 2x plus 3. Okay. And g of x is equal to x plus 5. We don't really have an elimination strategy readily available because we can't eliminate the x terms by adding or subtracting these together because we can't combine with that x squared. But we can absolutely use a substitution. We can say, when does f of x equal g of x? Kind of wish I had written that backwards. Okay, when does g of x equal f of x? So I'm saying, when does x plus 5 equal x squared plus 2x plus 3. Okay, now simplify. Subtract x from both sides. Notice I line up my inverse operation with the common, the like term, and minus 5 from both sides. Okay, so this is going to be equal to 0 equals x squared plus x minus 2. Okay, and now we need to, let's try factoring that, because if we can factor it, we'll find out what values of x make this 0. Looks like 1 is a possibility. Is there another possibility? Let's find out. Okay, so 0 is equal to x plus 1. So multiplies to minus 2 and adds to positive 1. X minus 1, sorry. X minus 1 times x plus 2. See, that factors. All right, so two numbers that multiply to negative 2 and add to 1 are those. So x equals negative 2 or x equals 1. All right, so there's the two x values of the two possible solutions. Let's use the function g of x to evaluate the y values. So let's find g at 1 is equal to 1 plus 5. So g at 1 is equal to 6. Let's find g at negative 2 is equal to negative 2 plus 5. G at negative 2 equals 3. Okay, and let's put them in there. So my answers are, when x is 1, y is 6. And when x is negative 2, y is 3. Let's try level 2. Find the solution of a system of equations algebraically. So I noticed that this one can be written as a function, so I did. The next one can't yet, so I'm just going to do some scratch work on the side. 2x plus y equals 11. Solve for y. Y equals negative 2x plus 11. Just subtract 2x from both sides. So I have a g of x here. G of x equals negative 2x plus 11. And I'm looking for, when does g of x equal f of x? Well, let's see. Minus 2x plus 11 should equal negative x squared plus 26 at some point. Move everything to one side. 0 is equal to negative x squared plus 2x minus 11 plus 26. So I'm going to minus 11 from both sides. Just to show you there, this is plus 15. Note I added 2x to both sides. There's no like term there, plus 2x, so you saw it showed up there. All right, let's keep going. So now let's solve this one. Well, it would be easier if I just flip the signs, right? Let's multiply both sides by negative 1. 0 times negative 1 is still 0. The point is here, I'm allowed to multiply by negative 1 because I am changing the thing, but I'm not changing where it has zeros. 0 is equal to x squared minus 2x minus 15. Multiplies that number to numbers that multiply to minus 15 and add to negative 2 are x minus 5 times x plus 3, and that's 0. So x is equal to 5, or x is equal to minus 3. So now let's grab g of x, and we'll grab those two values, 5 and minus 3 that we got from factoring, and we're going to evaluate where does g of x equal. What does g of x equal at those values? So g at minus 3 equals minus 2 times minus 3 plus 11. Sorry about being right on the edge of the page there, but I think you got the idea, I hope. G at minus 3 is equal to minus 2 times minus 3 is 6, plus 11 is 17. There's one of my points, minus 317. And let's try g at 5 is equal to minus 2 times 5 plus 11. G at 5 is equal to 1. Okay, so we had minus 3 comma 17. That should be in brackets to make Delta Math happy. And put the brackets in, boop, boop, boop. And then we have g at 5. When x was 5, y was 1. Two solutions, submit answer, yes, yay, do that. Okay, last ones, linear systems, level 3. Okay, why is this harder? I don't know. Let's find out. Maybe we're going to need quadratic formula. Oh, maybe because it's an A that's not 1. I don't know. All right, so you can visualize these two. You always want to practice that visualization because it can give you clues. Okay, here's what I'm seeing in my mind when I look at that. I have a very stretchy parabola that crosses up at 8 at a steep slope downwards. It's like this. It probably doesn't cross the y-axis. It probably doesn't have roots, this y equals blah, blah, blah. And then there's 2x minus 1. So it's down here, and it's going up pretty steeply. So this might be a case where there's no solutions, or maybe there's 1 or 2, but they're certainly going to be in the positive quadrant up there. So let's find out what they are. And that's going to guide my error checking. Gives me something to imagine. Okay, so I have f of x equals, and you don't have to convert these to function notation, but I much prefer function notation to saying y equals. It's just far cleaner when I have more than one function. 2x plus 8, and g of x equals 2x minus 1. Where does g of x, 2x minus 1, equal f of x, 5x squared minus 12x plus 8. Let's subtract 2x from both sides and add 1. 0 equals 5x squared minus 14x plus 9. Okay, can I multiply to positive 45 and add to minus 14? So I'm playing an x game in my head. Yes, I can. Minus 9 times minus 5. You want to write out your x game, that's fine. It's pretty easy here. When the coefficients add up to 0, it is factorable. Because there is a solution for x here, a solution exists, then we know that that solutions exist to this. So my visualization said maybe we don't have solutions here, but no, we do have solutions. Okay, so if you get a case where you can't solve this, there's no values of x that make this true, it's a situation where the line doesn't hit the parabola. That's absolutely possible. Two lines will always touch unless they're parallel. A parabola can just totally miss a line. It's possible. Or it can hit at one point, but that's very rare. That's hard to do. Okay, let's keep going. All right. So I know that 0 equals 5x squared minus 5x minus 9x plus 9. Why am I down there? Let's move me up here. And then we would have 0 is equal to 5x times x minus 1 minus 9 times x minus 1. This is equal to 5x minus 9 times x minus 1. 0. So x is equal to 9 over 5x, 9 over 5, sorry, or 1, x minus 1, and the bracket, yeah, or 1. Okay, so now let's use g of x. Okay, so I'm just going to copy it here. G of x is equal to 2x minus 1. Let's solve this one. When x is 1, we know we have a solution. So g at 1 is equal to 2 times 1, which is 2, minus 1 is 1. So the point 1, 1 is one of our solutions. The other one, we're going to want to use fractions for 9 over 5. So let's do that. All right, so let's evaluate what's g when x is 9 over 5. Well, that's going to be equal to 2 times 9 over 5 minus 1. This is equal to 18 over 5 minus 5 over 5. This is equal to 13 over 5. And the same person that loves Fibonacci numbers is at work again here. So this is 9 over 5, comma, 13 over 5. Submit answer. Hooray! Do those in your head for big, huge super points. Any questions, absolutely hit me up by email. Send me screenshots of the problems you have trouble with, and we will be teaching this next week. Any questions, you can also find me on Tuesday. Bye for now, everyone.